So my name is Viktor. I work for CloudBees. CloudBees is a company behind Jenkins. We do Jenkins stuff. I work a lot with Docker engineers. I'm not employed by them, but you can say I'm an evangelist or something like that for them. A couple of books, not important. So Docker containers. Who's using?
No, go back to books, please.
Yeah, those are okay. The third one, don't bite. It's really awful. And I'm not exaggerating. It is. The first two are good. If you want to go into DevOps stuff, this is DevOps in general. This is about Docker Swarm in more details. Buy it now. That's commercial. Okay. Enough of books? Excellent. Who's using containers today? Okay, so I don't need to tell you what containers, most of you, what containers are. They're portable, blah, 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 blah. Bare metal, okay, skipping. Huh?
This is going to be fast.
Yeah, it's going to be too. No, I want to go to the hands-on part as soon as possible. Just like with books, say stop and I go back and explain you what containers are, right? You know what containers are. They're cool, they're sexy, and all those things. We were using monoliths in the past. Hopefully, we are not going to use them for long because they're awful. We are using microservices today because they have many advantages. Advantages is that we can have small teams working on applications, have autonomy, and all those things. Right. Going fast. The reason why are we using microservices now? Microservices exist for a long time, right? Who's using Linux? You're using microservices. Linux is microservices. Linux is a bunch of small programs that do a very specific type of tasks, and then you combine those programs into a pipe divided by pipes. Input of something becomes output of and becomes input of something else, and so on and so forth.
And
Linux is microservices.
And then it doesn't work.
Linux.
No, I mean the pipe.
Yeah, of course. If you don't know what you're doing, it doesn't work. For the rest of you, it does. I'm kidding, partly. So why are we using microservices now, and why weren't we using microservices or services before? And we were not using microservices before because they were very complicated to do, and complicated for many reasons. One of the reasons is infrastructure. Because if you're going to have hundreds of services, and each of them developed in whatever the team thinks should be developed in, and we want that because we want to give teams autonomy. You can do it in Go, you can do it in Java. Don't do it in Java. You can do it in Go, you can do it something else. That's okay, but it produces huge problem with infrastructure because how you're going to set up servers that can actually support anything that anybody can ever imagine, right? Very complicated. Java 7, Java 8, oh no, I want Java 6, no, I want Java 4, and I want Golang. It's really, really complicated to set up infrastructure for microservices. Now, with containers, and that's the reason why actually everything is coming now together with containers, all that infrastructure mess becomes relatively easy. Not easy, but still much easier than before. The reason is because inside of containers you can put everything you need, and that's completely isolated from any other. It's not completely processes inside of a container isolated from processes inside of some other container. So you have no conflicts in that sense, and your infrastructure is basically bare metal with only Docker and nothing else, right? And that's why Red Hat is now going crazy, trying to completely destroy Docker, because if Docker succeeds, then Red Hat is going to completely disappear as OS because there is no real reason to have Red Hat or Ubuntu or something like that, right? Complete change in how we manage infrastructure today. Am I going fast?
Yeah.
Yes. Complete change in how we do infrastructure.
The stuff with Red Hat being distinguished, how's that going to happen?
How is that going to happen? Let's say that we all adopt containers.
Okay.
Imagine. I'm not saying that, right? What do you need if you want to run containers? You need OS that has Docker engine and 3 more things, right?
Which might be Red Hat.
No, Red Hat is not 3 more things. Red Hat is 300 zillions of things on your OS, right? You don't need all those things. And we want to go minimalistic, and we put all the things that we need. That's why CoreOS started getting popularity. Ubuntu Docker is becoming popular. New OS, I'm not allowed to speak about it, but new OS from Docker is also coming out, and so on and so forth. Many Linux distributions. It's still going to be Linux. It's just this distribution of the Linux is going to be much more minimalistic, right? Because things are moved inside the containers and not running on OS.
I see.
Right. And that's why Red Hat needed to join forces with Google. Now they're fighting against Docker and a few other concepts and companies that are moving in that direction. Okay, so and another reason why things are becoming different is because we are now going into immutable everything, right? You're not supposed to change anything in your host. Everything is immutable. Everything is unchangeable. Meaning containers are immutable, and you're not supposed to even to have SSH access to your servers because you don't need SSH access anymore. If you need SSH access, you're doing something, either two options: you're doing something terribly wrong, or you have your cluster is 2 servers in total, right? Very small. Okay. So problems with all that is that changes become a cluster, and when I say cluster, everybody says we have a cluster. The fact that you have like a couple of servers or a couple of tens of servers does not mean that you operate on them as a cluster. Cluster means that it's a one unit. It's not kind of, you don't deploy to a server X. You don't put the name to your server and say this server is called Garfield, and that's where I'm deploying my my application. Now you deploy to a cluster. Cluster has, I don't know, 200 CPUs, terabytes of memory, and stuff like that. It's one unit, no matter how many servers it has. Pretty much like big guys, unicorn companies are doing for a long time. Like Google, for example, has containers, I don't know, 15 years. It's just that they were very hard to manage. So now, if you start using a cluster, then that means that you need to change your architecture. And that means that you need to start deploying immutable artifacts, containers, or immutable even VMs. We were doing that before containers. You're starting to build stateless services. Services need to be stateless if you want to do what I'm going to present here, because if they're not stateless, then you cannot scale up. You cannot recuperate from a failure. You cannot do many of the things that we want to do today. And everything communicates through service discovery. Who knows what service discovery is? Excellent, half. That's a good percentage. For those of you not, in other words, what using service discovery means that whomever of you is using configuration files, throw them to the trash because they cannot be used anymore. And the reason why you cannot use configuration files is because you don't know where things are. Because you cannot put in a configuration file and say, this is the IP at the port of my database. Because database might be here, and then the server might fail, and it will be recuperated somewhere else. So things are all the time moving, fluctuating, and if you hard code values in your code or configuration files, you're going to fail as well with those services. So configuration files out, service discovery becomes a norm. And we need new processes. Agile, right, appeared, I don't know how many, 20 years ago, 15 years ago, nobody knows, appeared a long time ago, we all like it and all those things. And you change drastically how we develop software, right? We develop in small iterations because waterfall nobody wants to use anymore, and self-sufficient teams. Now, self-sufficient teams, that's a problem because Agile teams were never self-sufficient. Never, right? Self-sufficient in Agile terms means that I have all the team knows how to gather requirements, how to develop, how to test, right? In Agile, that's not really self-sufficiency because they don't know how to deploy code and they don't know how to monitor the deployment of the code and recuperate from failures automatically. I mean, some Agile teams do, but it's not really prescribed as part of the Agile movement. So from Agile movement, more or less, in most cases, we exclude completely operations. Like you're Agile, and then you have a department of operations that you need to wait for 2 months until they actually do something. Now we go to DevOps. DevOps is in a way continuation of Agile. It's kind of evolution of Agile, at least how I see it. It really makes the team being truly self-sufficient because it includes all the operations and monitoring and God knows what tasks that we were doing before, separately from the development teams. The result of all that is that we can finally do many funky things that we couldn't do before, or we couldn't do before really well. And one of those things is continuous deployment, my favorite, meaning, you know what continuous deployment is, right? Also, you commit something to repository, and from there on you go and take a coffee because things are going to get to production in a fully automated way, and there is no manual action after the developer commits code to the repository. So, The thing is that now you need to know your more times the things. You're not a coder, you're not a tester, you're not an operator. You need to know everything and then specialize into whatever you want to specialize with. You need to understand the process, because if you don't understand the process, and if you're not capable of doing all steps in a process, then you don't know how to do your job either, because you don't know how to, you cannot really design your services well if you don't know how they operate with other services. You cannot design your services well if you don't know how they're going to be deployed. You need to know all those things, only to go back to what you're really doing your specialization and do it right. Right. So, I said I'm going to go fast. Any questions before I start doing, showing you some code? Questions? Yes, please.
One general. So, microservices as a concept, in your experience, would you dig into microservices? For example, you're starting development, or you're part of a new effort to develop something.
Something new.
Something new.
Okay.
Would you dig into microservices architecture from the day one, or you would develop monolith?
No.
And then, if it needs, you would scale by introducing microservices and something.
No, I will start with microservices immediately, because if you don't start with microservices immediately, then you're gonna fuck it up in a monolithic way, and then you're gonna have problems to do it afterwards. Microservices are not really hard. Microservices are, in a way, the same thing as object-oriented programming. I would even say that
it's easy to implement, but it's
yes.
so hard to maintain. It's so
Right.
difficult to deploy because there's so many moving parts. You need people to.
Okay, I make a deal with you. I show you the code, and after that, if you continue telling me that it is hard, we're going to discuss it.
Okay.
I'm going to show you it's not hard.
All right.
Is that the deal? Excellent. Any other question? Yes, please.
You said that everybody needs to know everything, and then you specialize. Do you really expect every team member to know everything about how the pipelines work?
Yes.
About the infrastructure?
Yes. Yes. I do really expect that. Yes. No, when I say everything, I don't mean to be expert in everything. I'm not saying that. So I fully understand that if you're a coder, you cannot know everything there is ever to know about databases. Just let's move it a bit backwards in time, right? You're not an expert in database, I understand that. But does that mean that, for example, you're not capable when you do your code to do SQL query? Does it? No, of course. You need to know if you have enough knowledge about databases, even though you're coding your service, right? The same applies to, if you're a coder, that doesn't mean that you don't know how to test. You do write your tests, same thing, right? I'm just moving it a bit further and saying that you need to know how your service is going to be deployed. You need to know how your service is going to be monitored, because if you don't know, nobody can know. I mean, to me, it's a ridiculous idea to say, okay, I developed my service, here it goes, put it to production, and whatever is the team in charge of production operations will know what to do with my service. They have no bloody idea. Of course they don't. They can create tools for you to use, they can create processes for you to follow, but it's ultimately your responsibility. It's more or less what Amazon is promoting with 2 pizza teams. Do you know what 2 pizza teams are? So basically, I have a team that is sufficiently small that I can feed them with 2 pizzas, and they're responsible for a service. Meaning that if it fails 3 o'clock in the morning, they'll call somebody else, some random operation dude to fix it. It's your service, you did it, you fix it. That's attitude. Does it answer?
Yeah.
Okay, so let's see. It's very likely that network is going to fail, so let's see whether this will work. Right. So I'm going to go to one of my services. So this is no, this is not. This is my service. It's called Go Demo. I already created. The only thing that I did in advance, I created the virtual machines on my laptop. Yeah. By the way, if you want to do the same thing that I'm doing, this is the address of the presentation, only the highlighted part. I advise you not to do what I'm doing, simply because network is almost certainly gonna fail. You can do it at your home, but if you insist, you can do it here, what I'm doing as well. But then you need to tell me to slow down too, because I'm gonna go out too fast. Okay, fair enough. So let's see. I have a single machine right now. I'm gonna instruct my local Docker client to point to that virtual machine so that I can do things remotely against that virtual machine. So, let's say that I have a service, and I do have a service. Let's say that I did a commit to repository, which I did. And the first step in my pipeline or my deployment flow, or however you want to call it, would be to run unit tests, right? First two actually steps are to run the unit tests and to create a binary from my code. It's Go, so it requires a binary, right? Most languages do. And by the way, this machine that I'm using right now has absolutely nothing but Docker, right? And I assume, when I started Teams, I assume that you know what you're doing with your service, and your server is going to have nothing but Docker. I don't care whether you're developing in Node.js or Python or Java or whatever you're doing, right? So, and we made, let's say that we made naming convention, and then we all agree that the unit tests are going to be called units, right? Just a naming convention, nothing else. And the team comes and say, okay, excellent, I have a service is right. For me to run unit tests, I need Go, because service is written in Go. So I'm going to use image called Golang version 1.6, right? And inside of container, I want to expose the current directory, wherever I am right now, is to be inside of container this directory, USR, SRC, my app, doesn't really matter. And I'm going to expose one more directory from the host, TMP Go, to be inside the container is going to be mapped to directory Go. The reason for that is because Go will, like most languages, will, before it runs tests, it will download dependencies, and I don't want to download those dependencies every single time I run unit tests, so they're going to be persisted on the host. Working directory, this is what's going to happen, but actually, basically, the only really important thing is this. I'm not going to teach you Go today. Anybody working with Go? So I'm going to download my dependencies. Command is really not important, just to know that the dependencies are going to be downloaded. I'm going to run my unit tests and get a test coverage report. And I'm going to build my binary, right? I'm doing the same thing as I would do without containers. The major difference is that things are going to happen inside of containers, so they have no dependencies to the infrastructure, right? Doesn't really matter what my server is, doesn't matter what's installed over there, as long as it has Docker engine, it will work, right? So if and I'm going to run it with Docker Compose. For those of you who don't know what Docker Compose is a way to declaratively specify in a YAML format all the arguments that you would normally run manually if you would do Docker run blah, 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 blah. So I'm going to run, so I say, okay, I don't know really what you're doing. We agree that your unit test will be called unit test. I don't care what's inside. I'm going to run a command for every service that is going to be always the same. It's going to be Docker Compose. -f is the name of the Docker Compose file. I want to run whatever is there. I'm going to use argument --rm. That means that when I'm done with this container, when I'm done with unit tests, I want you to remove it completely because I don't need it anymore, right? That's kind of leaving my server, resources of my server available for something else. I hate running things unless it's really needed. And finally, the service I want to run is called unit, right? Now let's see whether the network works. And this is a good, yeah, I downloaded the MongoDB driver, among others, because the service needs Mongo. I have to download a few other things before it continues. Questions?
Our Docker Compose, you had like an app image, then a unit. I don't really understand the meaning of.
Yeah, this, you're referring to this, right?
Yeah, and the app.
Yeah, so in Docker Compose, you define services, right? Service, this is the name of service, this is the name of the services, whatever you want to put. It's a name that it's provisional, whatever you want to put. And inside of a service defined by a random name, you use Docker Compose syntax to define stuff. This is a base image Golang, volumes, working directory, and command interface. Does it pass?
So the app there is like a what or the other?
No, the app is another service, and this one I will use soon to build my container later on, my service. And I have here, for example, another service called staging depth. That is going to run my service in a staging environment and has a dependency on database and so on and so forth. I'm going to go through all of them. But I think that the only important thing for now is that you can define as many services as you want, and each of them has different meanings, whatever you want it. the meaning want to be. Okay, and my tests are finished, right? All of tests passed. I'm a really lazy programmer, only 66% coverage, and everything is really peachy. Now, this in itself already would be probably, if you went to your IT department or whatever you have in your company, and you told them, hey, you know what, I need to go compiler running on a server, and I need MongoDB, and I need a bunch of other things, they would probably tell you come back tomorrow. And that's only if you're a very fast company. If you work for one of the major banks in Spain, they would probably tell you come back in 6 months, and you will not get it then either, because we don't allow anything that is not Java 4. And if you remember, when I run the command, if I go back, where is it? Yeah, so I download the dependencies, I run my unit tests, and I build my binary, right? So if I look at my directory, you can see that my binary, the result, my service itself, is built as part of my process, right? And it's something on somewhere on my hard disk waiting for me to do something with my binary. So let me build the service. Now that I know that service first round of tests worked, unit tests were successful, I can build my service. And to build the service, use something called Dockerfile. Dockerfile defined everything that the service that the service or application needs in order to become a container one day. In this case, I'm telling it to use Alpine. Alpine, any of you know what Alpine is? Excellent. For the rest of -2 of you, Alpine is a Linux distribution. It's very lightweight. It is maybe 2 megabytes or something like that in size. And most of people now with Docker move towards Alpine simply it's very lightweight and doesn't occupy much resources nor hard disk. Maintainer is just for information, has no real purpose, just gives you information who is in charge of that service, so if you can contact him when it fails. Run, run is equivalent to running any shell command. It's actually not necessarily shell command, it can be any command that is available in your base distribution to use. In this case, I'm creating a directory, creating a soft link, some stuff related with Go. Not really important. What is really important is that I can run any command I want. Then I'm telling it to expose port 8080 because that's the port my service is listening to. Now, when I say expose port 8080, I'm saying when this becomes a container one day, this is the port inside of the container the service or application is listening to. What will be outside of container is a completely separate story, right? I'm going to get there. I can define some environment variables. For example, I have an environment variable DB that the code of my service uses to know where is the database, to know the address of the database. Environment variables are a much better option to manage, at least in containers, to manage things than configuration files. So my service is going to connect to the database, to whatever is the value of the DB environment variable to find the database. Next is command. So CMD is a command that will be executed when a container starts one day. So when it starts, it will, in this case, it will execute the binary of my service. Health check is a new thing that appeared a few months ago. When this becomes a container, Docker will run whatever I specified the CMD of health check, and periodically, and use the output of that command, whatever the command is, to decide whether the container is healthy or not. If it doesn't care what the command is, the only thing it cares is that if the command after CMD returns 0, container is healthy. If it returns anything else, it's unhealthy. And depending on whether it's healthy or unhealthy, it will do one thing or another. There are quite a few arguments you can use. In this case, I'm using just one, and that's immutable. So Docker Engine will run this command every 10 seconds, right? Every 10 seconds, we'll check whether the service is healthy or not. Finally, the binary that I built before, that is now on my hard disk, I'm going to copy it inside a container in this path, and I'm going to give it execute permissions.
Quick question while we are there. What is the best way to provision these kind of files? Because now we have a lot of hard-coded things in there.
Hard-coded? What's hard-coded?
Paths, the names, the ports. So, what, in your experience, what is the best way to provision these things?
Well, I'm not sure what you mean by provision.
Something like using Puppet or...
No.
Where do you have these files stored?
I have it stored in a repository where my code is. And this is the definition of each of those instructions is become an image, immutable image, unchangeable. And all those images together will form a container, if that answers your question. And how do you create those images? If that's the question, then you create it with a command I'm going to run in a second.
No, what I mean is...
How you edit this file, right?
How do you edit this file? Vim?
Yeah, but if there is any helper or something, no?
Helper, kind of like code complete stuff.
Yeah.
Depends. I use IntelliJ IDEA, and there is there might be a help. I don't know. I mean, I rarely use for those things code complete, but editors have it. I'm not sure whether that's your question or.
It's more like so you create this file and you save it, you push it to some repository, right?
Yes.
So when you build the whole pipeline, something will pull the file from somewhere, right?
Yes.
So how do you? Oh, I guess.
I mean, it will pull with my code. Let's say that I'm going to use Jenkins, and I will use Jenkins soon. Pipeline is first always starts with pull my code, right? Because I need the code to do unit testing, a bunch of other things, and among other things, I will have the Docker file. And then at one moment in the pipeline, it will build the images out of the Docker file. Consider this Docker file equivalent to Puppet Ruby files. So it's very equivalent. The difference is that Puppet is in charge of configuration management of a server, and this is on a smaller level.
This is like application configuration.
Yeah, it would be. Let's say that if this would be Java, let's say this would be equivalent to Maven. Right?
Cool.
Maven would build a jar file. The difference is that I'm not with Docker file. I'm not building a single artifact like jar file. I'm building the whole stack.
Okay.
Everything that the application needs.
Okay. Yeah.
One question.
Yes, please.
About the run, you have combined two comments. As far as I know, run makes a new commit with every run comment. So usually you have to combine as many comments as you can for a single unit of logic, or you try to keep the number of run comments to the minimum?
Yes, that depends. Yeah. Before I answer that, I need to go back for a moment, and then I'll answer. So when I execute Docker build, that will build all those images. It goes from top to bottom. Each of those instructions is an image, right? Now, almost there. And the order of things here is not random. It might not look logical. The order is very specific because the way how it will build is going to start the first instruction. Did I do this before? Yes. Okay, I'm not going to do it again. I have the image cache. Did I do it? Yes. No. The moment it finds an instruction that will produce a different image, it will build everything from there down. So I'm always trying to put things that are more likely to change down and things that are less likely to change up. And that's the reason why actually copy is almost at the bottom, because most likely this is the only thing that will change in every release. Now going back, in this specific case, this could easily be 2 runs, and the result would be more or less the same. It would be 2 images instead of 1, but the total size would be almost identical, maybe slightly bigger, but nothing to concern. But let's imagine a different case. Let's say that you wanna download a zip file of something, extract it, right? And in that case, run would be, doesn't matter whether it's one or multiple, commands would be install zip, unzip, right? Download whatever you want, unzip it, remove zip file, and remove zip binary, right? Now, if all of those are different layers, and remember they're immutable, the total sum of all that would be would not be reduced by you removing the file, because the file is still in the previous layers. You understand what I mean?
Yeah.
And in that case, it's preferable to actually put it all in the same run instruction, so that actually everything becomes one single layer, and then the size would be smaller, because at the end of that layer, before the image is created, you're removing the files that you don't need.
Okay.
Yeah? Okay, so let me build the app. If you remember before, where was it? Yeah, here. Docker compose test local. Here I have another service. I slightly commented before, but it's very simple. I use it only for building the application or service. It says build whatever is defined in a current directory. By default, that's a Docker file. You can change the name, but default. And the result of that will be an image called Go demo. Right? So I'm going to run that. So Docker compose, same like before, just this time instead of run, I say build, and the service I'm building is called app. So it goes through all the instructions, builds all the images, creates one Uber image, and if I list the images I have on this host, ignore all the rest, my image that I just built 10 seconds ago is there, right? And my service is in total, and I mean now binary, but the whole everything, call it a server, everything that requires is 23 megabytes. Now this is a demo application, but real production applications in Go, for example, will still be not more than 50 megabytes in total, right? Very lightweight. It all depends on the language and the framework you use. It can be bigger or smaller, but we are trying to be minimalistic when possible. So I have my image there, still not doing anything, just it's sitting on a hard drive, waiting to be used. So let's take a look at, now that I have my image built, next stage, next part of my pipeline would be that I want to run staging tests, functional tests, whatever you want to call them, tests that require my application to be running, right? Unit tests assume that its name is bad. I usually don't call it unit, I would call pre-deployment tests and post-deployment tests, for example. So for staging tests, I cannot simply run tests. I need to do it in two phases. First, I need to run the application, the service, or whatever you want to call it. And by that I mean not only the service that I'm developing, but I need to run all the dependencies, right? And in this case, so I'm telling it, okay, I want you to run images called Go demo. That's the image that I just built. Right? The internal port 8080, I want you to expose to outside world this port 8080 as well, so mapping one-to-one. And this service depends on a database. It uses database. And database in this case, it says depends on database service. And database service here is a very simple one. It's MongoDB. I don't need anything but MongoDB. Normally it will be my custom image that might have some modifications to MongoDB and all those things. But for now, Mongo official image is just enough. So if I run my dependencies, I can run them with, again, Docker compose. Now it's a slightly different command. It says up. Up and run are almost the same. The major difference is that we expect run to be something that lives for a limited amount of time. And up is usually used for services that are supposed to run infinitely.
Now you're running end-to-end test, and
not yet. Soon, yes.
Yeah, but soon. So it will create the whole ecosystem.
Yes.
Right?
Not
So
the whole ecosystem. The whole ecosystem needed for that service.
Okay.
Not necessarily, yeah.
But let's say that you want to do an integration test of some top-level service, right? It will have many dependencies, sub-dependencies,
Yes.
etc. So you need to kick off the whole thing. So it will be very expensive, I guess, to run this integration test.
That depends on your architecture to begin with. Not more expensive than without Docker. That's the question. It will allow me, for example, one of the ways that it would be much less expensive is that when I'm done, I can remove everything I do and leave free resources for something else. So dependencies, whatever your dependencies are, you need them with or without Docker. The major difference is that I can create the system in a second, and I can destroy the system without danger of actually infecting somebody else. But your dependencies are your dependencies. This is still kind of functional tests. It's not full integration test. I'm going to get to full integration tests soon, right?
Okay.
It's kind of minimum number of dependencies for a service. Usually, if a service needs a call infrastructure for this type of test, then you're probably doing something wrong, right? So let's run it. And so it's called staging test, right? And I run it, and let's see the result. It says already here, it created the database, it created my service. Then if I release processes, it's a PS command, I see that on my system, those two other containers are now running, database and the service that I built before, right? It's running, I can do whatever I need for them. Now pay attention that my service is exposing to outside world port 8080, so I can test it through its API, for example. But database is completely inaccessible to anybody, to outside world. You cannot access database. However, since both services depend on the same, they call it project, software-defined network is created around them. So those two containers can't really communicate with each other. They cannot be accessed from outside of that network unless you expose a port like this one, right?
So you don't need to tell them another configuration.
No. All I had to do is if I go back to here. No, sorry. You remember the environment variable DB? The default value is DB, and that happens to be the same service defined in Docker Compose file. So what Docker does, among other things, is that when you run those services, it will create a separate network with DNS the same as the name of the service. So there is an endpoint called DB, and there is an endpoint called staging depth, because those two services is what I run, right? You just by invoking the name of the service, you can do. There are actually more DNSs created, but those two are good enough for now.
Just a quick question. What version of VirtualBox are you using?
I'm not using VirtualBox. No, I'm not using VirtualBox. Yeah, VirtualBox, yeah.
It's crashing in my machine.
Is it running Windows?
No.
Okay. I'm sorry, kidding.
Okay, I saw it. Okay, it's 5026.
Yeah, and yours older or?
Is there any reason you are not using the Docker for Mac?
Yes.
From the performance?
For what I'm doing right now, actually, I could use Docker for Mac, but soon I will start doing showing you how to do things inside of a cluster, and for that reason, I need multiple machines running. If it would be only this, I would run it for Docker for Mac. And performance is definitely not lower than Docker machine, if that's the question.
File system, but if you are not using volumes and other files.
Yeah. We can discuss volumes. You shouldn't use volumes in many more cases than people usually do. Where was I? Yeah. Any other question? How are we with time? Oh, only an hour pass. Half of the time. We won't get far. Okay, so now I can run my staging tests, right? If you remember, my staging tests are almost the same as unit tests, and that's why I'm actually extending. I don't like to repeat myself, so my staging tests are extending unit service because it's very similar. I'm creating an environment variable that my tests use, host IP, that tells me what is the address of my of the service it's going to test. Network mode host by default is bridge. When it's host means that it shares the same networking as host. In most cases, you shouldn't do that, but this is quite okay. And I'm running, in this case, Go command again, download libraries, and run another set of tests, this time integration tests.
Why staging doesn't depend of the other services?
Say again?
Why staging is not depending, doesn't have the depends on?
Staging. Okay, because I want to run those as long-running services with Docker Compose up, and this one I'm going to run with Docker Compose run,
Okay.
because kind of do something and disappear. So I did not manage to combine them into one command.
Okay.
So I run my staging tests. Yes. Okay. The application seems to still work, right? All the staging or integration or whatever you want to call them tests were successful. And these are not unit tests. These are tests executed like black box testing against the API of the service, running service. Now, since I don't need any service anymore, I want to free resources for somebody else to do something else on the server. I can do Docker Compose down. Down is the equivalent for those of you who use Docker. It would be equivalent to Docker stop, Docker RM, stop and remove. This kind of combined command down that will stop everything I ever had, right? It removed networking, it removed the applications running, and so on and so forth. So if I look now at my server is version, has nothing. You can do anything else in that server, whatever you need to be done. So the only thing now, before I move to cluster missing, is that I'm going to run a class service in this batch. It's called registry, because now this container is stored in my on the hard disk of this server. I want the result of that to be accessible to any server in my cluster. So I'm going to run something called registry. For those of you working with Java, for example, it's equivalent to Maven. Just that Maven story Nexus, for example, but instead of storing jar files, it stores Docker images. So blah blah blah. I'm going to run registry. So I run registry. Excellent. It's already running. Hopefully, Docker ps -i. Yeah, it's running. Yeah. So with registry means that if you do Docker pull something, it will get it from cloud, from Docker Hub in the cloud, as I did it now. If I can tag it and say, I want you to tag this image as localhost 5000/alpine. This is naming convention in Docker, meaning that if name of the image is prefixed with the address of registry, when you push it, it will be pushed to that address. So I can push the image that I just pulled, and now it's stored in my private registry, and I can do whatever I want with it. So this is a demonstration. The applications I just built, the images that I just built, I'm going to tag them localhost 5000. That's where my registry is running. I'm going to give it name go demo again, and I'm going to tag it as release 1.0. It's my first release of my service. And if I want you guys to access it, if you would have access to my laptop, I can push it. And from now on, anybody inside of my network can access this image and do whatever he or she needs to do with it. Yes, please.
Sorry. So the reason to use registry and not Docker Hub is to have a kind of cache in your system.
Yeah. There are a couple of reasons. First, for example, if it's local running in one of the servers in my network locally, the whole pushing and pulling will be much faster than if I go outside, for example. And also, if you work with enterprise customers, then they freak out when you say cloud and send it through the window.
Okay.
That would be the two main reasons.
So what happens if the Docker image fails to run or that gets corrupted or something like that? What if it's down or it doesn't work?
If it's down or if the image is corrupted?
In any case of failure. So because now you have this single point of failure, right? Your registry.
Yeah, you can run multiple registries in parallel. I never run anything in less than 3 instances, anywhere.
So it's like replica.
Yes, you can set up replication between different registries. And even if all of that fails, you can rebuild it just as easily as you build it.
Because it's immutable and has the things in a database or something like that.
Huh?
It's immutable, the registry as well?
Yeah, registry is storing everything in file system by default.
Okay.
And each image is actually, it's a very long hash that is based on the size of the image, a few other things. So it is, and it's immutable in the sense that you cannot modify the image once stored in registry. You can just push a new image instead.
Okay, so since the data is in the file system because it's mounted, doesn't matter because you can always run up another instance.
Yeah, exactly. Now, corrupted files in the file system can get corrupted as well. It's kind of like going through a rabbit hole. There is always somewhere in point of failure. Your whole cluster goes down. I don't know, but you can do replication. You can store it in a database instead of file system as well. You can use a couple of other solutions.
Backups.
Yeah, but in case of failure, the registry is the last thing I worry about, simply because it's so easy for me to actually rerun containers in a worst case scenario that I can always fix it. I can have a downtime of a few minutes, but that's about it. And if I mentioned file system, here is, for example, the directory. Now I'm exposed it to a host registry with 2 repositories, and if I go to Go demo that I just pushed, here are the layers, manifests, uploads, and all the files that it uses. So I'm going to destroy this machine. I don't need it anymore. Okay, fair enough. Now, Docker 1.12. Anywhere, those of you using Docker, did you try already 1.12? It's a new release. You did excellent. I don't know whether it's excellent for you, but it's a new release. It changed drastically how we work with containers. So if you're using Docker, I really recommend that you jump on board soon. Whether you might like it or not, that's a different question. Quite a new things. First of all, we go to service as a new concept in Docker. Service discovery now is part of Docker Engine. Before we would be running console or etcd or zookeeper, God forgive. Automatic failover that we had before, but now it works, so that's a big change. Networking greatly improved, rolling updates I'm going to show you very soon. So, I already created three machines called Swarm 1, 2, 3. Now, let's say that first of all, I want to create a cluster, right? But before I create a cluster, I'm going to run an application called Visualizer. Doesn't really matter the command for this case, so that I can show you how my cluster looks like. So, this is how my cluster looks like at this moment, meaning it's empty. There is no cluster at all, right? Tips and tricks. So my cluster is empty. I'm going to add one node to the cluster. Very easy. I'm going to say Docker Swarm init, the address of the node, of the server, and suddenly my cluster is one node big, right? I have one server cluster. Very cool cluster for now.
So this is the alternative to use console.
Not use with Docker Swarm or with what?
No, this visualizer and everything is like the alternative to have console.
No, this is for demo purposes. There's no real reason except me showing you demo. It's a shitty thing. Don't use it. It was developed for DockerCon just to show people how things look like. There's no real purpose except you seeing I have one server, nothing else. No, we can speak about that both later. So now that I created a cluster, if I want to add more nodes to a cluster, I cannot add it just like that. I need to run command Docker Swarm join token and give it information whether I want to add the worker or manager. The manager nodes are nodes to which I can issue commands, do this, do that. Workers just do the work of some work on a server. Manager is a worker at the same time, has dual purpose. So I want token, security token, for a worker to add more nodes to my cluster. I put it to environment variables token. So I'm going to now add 2 more servers, Swarm 2 and Swarm 3. And the only thing I have to do is say Docker Swarm join, give it token, give it the address of worker, and give it the address of one of the managers, right? So now I said, okay, this node joined the cluster, this node joined the cluster. Now my cluster is like this. I have 3 servers in my cluster, right? Now it's something that we can work with. It's still a very poor cluster, but that's okay. So if I do docker node ls, I get a list of all my nodes in a cluster. I don't like UIs, I always operate on command line, so this is equivalent to what you're graphically looking in the other screen. I have 3 clusters, one of them is a manager and is a leader at the same time. So this is how my cluster looks like, nothing really running there except Docker engine. So first thing I'm going to do now is I'm going to create 3 networks. I created a network called proxy, I created a network called GoDemo, and if I list all my networks, and from now on everything I do is on a level of a cluster. I'm not operating on a single machine anymore in any formal way. Everything applies to the whole cluster, all servers in a cluster. So ignoring those scope local, those are the default networks of Docker Engine. Here is one of the networks that I just created, and so it's everywhere in all servers. Here is the second network I just created, an ingress network comes by default. I'm going to show you soon if there is time. Yeah, 40 minutes. What the ingress network means. So this is how my cluster looks like: 2 networks and 3 servers, each of them running Docker Engine. So if I want to create a service, now I'm trying to do, I'm simulating my production here. I want to run the service that I just built, right? I told you already that my service depends on a MongoDB, so that's the first service I'm going to create. So I'm going to say Docker service create, give it some name, GoDemoDB. I'm going to tell it you belong to you should be attached to network GoDemo. I'm going to show you soon what network is. You should have 100 megabits reserved for yourself, and the Docker image that I want you to run is called MongoDB. It's official image from Docker Hub. And unlike the Docker Compose, Docker Swarm immediately responds with the acknowledgement. I understood what you want. It will happen sooner or later. We don't know when.
Service command is new.
Yeah, service command came with Docker 1.12. Public release was made 3 months ago, July, or something like that. June, July. Okay. End of June.
So what is it, the service command actually, what it does?
It creates a service inside of the cluster.
When you say service, it's something related to HTTP or?
No, service can be non-HTTP related. It's, service is your application running somewhere in the cluster.
So what's the difference between that and normal image?
No, it is still a normal image. The command is different because now I'm operating, service operates on a cluster level, and what I did before was on a single server level. Because to begin with, where is this service running now?
Somewhere in the
exactly. We don't know even where. Because the major difference is that when you do Docker run command or Docker compose something, you're imperatively telling Docker engine what to do. In Docker service, we are not telling Swarm what to do. We are telling Swarm what is our desired state. And our desired state in this command is that I want MongoDB to be running. If it fails, it will be rerun. If the node disappears, you will see soon what will happen. So it's, Swarm is continuously monitoring the cluster and making sure that our desired state is fulfilled at any given moment. Yes,
and you can say, for example, that you want 3 instances of these.
Coming there. Give me a second, okay? So now if I look here, it happened to be on Swarm 1, it could be running anywhere else. It's just for visualization purposes, right? So let's see. If I list my services, slowly getting to your question, last question, you can see that there is something called GoDemoDB. The image is Mongo, and it's finding 1 out of 1 replicas, because I did not specify anything different. So let me run the service that I just built. It's very similar. Docker, pay attention, for the database I'm running, I did not expose any ports. For this one, I'm also not going to expose any ports. Even though it's API, it's supposed to be accessed from outside, and I'm going to expose ports because that's coming later. So until now, everything is inaccessible to anybody. So service create, give it a name, GoDemo. Environment variable DB, if you remember from before, now I'm giving it value, GoDemoDB, that's the same value as the name of the service of MongoDB that I ran before, right? I want it to be
a reference to the previous service,
yes,
to be able to communicate.
Exactly. I mean, it's in reference used internally inside of my code. I'm checking for the environment variable DB, and whatever is the value there, is going to be used by my code. My code is going to take that value, say, okay, so value is GoDemoDB. So the address of database is GoDemoDB.
So it's a DNS name referring to the other.
Yeah, coming there as well. So you should belong to the network GoDemo, the same network as database is belonging to, and then also additional network proxy I'm going to show you soon. Why? This is the image that this time I'm pulling from Docker Hub, but I could pull if I didn't destroy the server from registry local as well. So now, I should tell you that the code of the service is made in a way that as soon as the service starts, it checks the connection of the database immediately. If it could not establish the connection, it would die. The service is designed in a way that it would die if it could not. There is no retry, anything like that, just die, right? I'm a very destructive person. So it says, okay, acknowledged, I'm going to run it somewhere. Let's see what happens. Bada bing, bada boom, soon, maybe, we don't know. Something doesn't work. I knew that it could not go as smooth as I hoped. So let's see my service. I can run Docker service PS. Docker service ls gives you the list of all services. PS gives you the details of a specific service. So let's see. Okay, it's running already for 8 seconds. This is the name, this is the image, this is the node where it's running. Desired state is running, and the current state is running for 8 seconds. So it was a moment ago. Let's see. Yes, it's running somewhere inside of my cluster. Since there is a network that spans the whole cluster, if this did not work, if GoDemo could not communicate with the database that's running on a completely separate server, it would fail, it would not work, right? So obviously the communication between those two, even though they're running on a separate server, is working just by invoking DNS GoDemo DB. Now, if you're masochist and you like more information, then you can run Docker service inspect and get more information about the information about the service. If you remove pretty, you get the same thing in JSON format with more information, blah, blah, blah. And you can see everything you need to know about your service. So my service looks like this now, right now. Database is running somewhere, the service is running somewhere else. They're all connected to the networking created before. Now, to demonstrate network, I'm going to create a third service. This time, Docker service create. I'm going to give it a name util. It belongs to both networks. Mode global. Now, mode global is special. Mode global means that by default, mode is replicated. It's what we did by now. Mode global means that an instance of this service will run on every single node of the cluster. If we create a new node later on, it will run there as well without me doing any action. If it's removed, it will be removed, and so on and so forth. So the image I'm going to run this time is Alpine. I just want to use it as a shell to demonstrate some things, and I'm going to let it sleep for a very long time, so otherwise it would fail and be restarted somewhere else. So service is running. Let's see the process of the service. You can see that now this service, unlike previous ones, is global. It's running on every single node of the cluster, right? It's running on swarm 1, 2, 3. I'm going to find ID of the service, complicated command, don't worry about it, you can Google it. And I'm going to install, I'm going to now execute some commands inside of one of the containers that form this service. And I'm going to install something called drill. Any of you used drill before? No? Drill gives you information about DNS information, that's what it does. So I'm going to execute the command inside of a running service, and I'm going to say drill go demo. Let's see what go demo gives us. So, Go demo is one of the services I ran before. And it says, okay, so the answer is 1, meaning that actually I could communicate from this container, from this service to the Go demo service. And the IP, this is virtual IP, is 10.0.1.4. You don't need to care about numbers, you just need to care about the name of the service, but that's the IP if you're really curious. And if I go to the YouTube container again and the drill go demo DB, I get also answer successful, and this time I got a different IP. And now what you should understand that this is IP of a service, not of an instance. At the moment, all of the services run only one instance, but still remember for later, this is DNS of a service, not of a specific instance.
The load balance.
Yes, load balancing.
That means that it's automatically doing load balancing.
Yes. I'm trying to half an hour, fuck me. Okay, so scale. I'm going to scale my service to 5 instances. Docker service scale, go demo equals 5, right? If I go to my fancy visualizer, nothing. Okay, this time for questions until it happens. No questions? Okay, excellent. Then trust me, it will happen soon. Let's see the process of this service. The process of this service says 5 instances of your service is running. So service is an abstract term. It's not kind of related to one instance of something. Service is a service, and then you can scale it up and down, whatever you want to scale. And if you look at the visualizer, yeah, praise the Lord, it's running all instances over there. So now it's scaled. I have 5 instances of my service, still 1 instance of database. I'm not going to scale database today because it will require more than 5 minutes. It has certain problems. that are Mongo related, not really Docker related, but that's life. So what happens if I destroy one node? I'm going to destroy a server. I'm destroying Swarm 3, right? Now what happens? Let's look at the process of Go demo. It happens nothing. Let's see what happens again, and again, and again, and again, and again. It's very slow. Yeah. So, So you see that actually desired state of one of the instances that were running on Swarm 3 now is changed to shutdown. The current state is still running simply because the node is disconnected from Swarm. Swarm does not know whether the node is dead or not. But what it does know is that it has no communication with that node, so its desired state is shut down. I don't know what's going there, but I assume that it's shut down. And it created a new instance on Swarm 1. And the other one that failed, it created a new instance on Swarm 2. So actually you get automatic failover as long as your services are designed to actually work in that fashion. And if you look at the visualizer, then this worker is now red, and the services that were running there were rescheduled on healthy nodes, right? The automatic failover, we all like it. So what happens if I add the fourth node to the cluster now? Because now panic, you receive emails, your node is down. There is no reason to panic because your services are still accessible, right? So no real reason to panic. Calmly, you can create a new node because even though all your instances are running, those servers might have a bit of overload on them. You know, too many things running there. That's not how we design. So I'm gonna run Docker swarm join a new node to the cluster. And now if I look at my util service from before, you remember that I put it as global. Now suddenly, automatically, it's already running on the fourth node because it's global. It should run everywhere, whenever the node is created or destroyed. So now the only thing missing that since none of those is exposing any ports, they're inaccessible from outside world. So I need reverse proxy. In this case, I have no time. We can speak afterwards in a hallway. I have no time to explain, but just remember that this is my own version of HA proxy. You know what HA proxy is, I hope. Okay, so I modified it so HA proxy can be configured by sending requests to it instead of changing configuration files. I hate configuration files. So my proxy is now running 4 instances. All of those 4 instances are running on Swarm 4. Why on Swarm 4? Because that's a new server that has resources free for something else. So I run 3 instances of my proxy there. We are all happy. So this is how my server looks like. Very complicated, whole mess. Everything is running there. We don't care. So it's called Dockerful proxy. The proxy that I modified, the HA proxy. So I can send a remote request to the proxy saying reconfigure yourself with the service called Go demo. This is the path of the service demo. I mean URL path. Right, the port that should be exposed, and I want you to distribute this configuration change to all instances of the proxy because now I sent it to one proxy, and then the proxy itself distributes it to all instances, so they're all equally configured. And if I was a bit slower, you would notice that I also run console. I use console to actually store the configuration in console, so in case of a failure, my configuration is safe instead of running on a file system. So now, if I ping you remember that proxy, all 3 instances are running on node 4? That memorized? Okay, excellent. I'm going to ping node 1, right? What happens? I get response. Okay. So I send a request to node 1, even though proxy is not running there. That's magic. So what really happens is that there is something called routing mesh. When I run my proxy and expose for the first time port 80, the proxy, that was just illusion. There was no port was exposed on the container itself. Port was exposed on a network called ingress that comes by default, right? And or the other name for it would be routing mesh. And that port was exposed on every single node of my cluster, thus allowing me failover. Because if I open only one port on one node of a cluster, that means that I have a single point of failure. Now I have port open on every single node of the cluster. On network port, not on a server, or not on a proxy service, so that I can actually send requests to any server and live happily ever after. So when I send a request for my service and you saw the response, I'm not lying, it said hello world, it's always hello world, the response tracked to 100. When I sent to one of the nodes, routing mesh kicked in and said, okay, so there is a request to port 80. which of my services inside of a cluster, somewhere inside of a cluster, I have port 80 open. In this case, a service called proxy. Okay, I'm going to reroute this request. What happened? I'm going to reroute this. Something happened with my slides. Reroute this request to one of the instances of the proxy. So my proxy is doing, remember, reverse proxy, nothing else. Load balancing is happening by Docker network, and it's lightning fast. So routing mesh took the request, forwarded it to one performed round robin across, in this case, proxy, right? Proxy got that request and said, what is the address that you wanna use? Because we cannot have more than one port 80 open, right? What is the address? Address is /demo. So /demo, I have it mapped in my configuration of HA proxy to be related to the Go demo service. But I'm not going to send you directly to one of the instances of the service because I don't have to do that. I'm going to send that to, you remember that I created proxy network? I'm going to send it to the proxy network because that's the network I belong to and consequently also the service that you want to speak with. So it's sent to proxy network, and proxy network again, routing mesh kicked in and load balancing. I'm going to resend it to one of the instances. I'm going to do load balancing. You do routing, I will do load balancing and went to one of the instances of my service. How much time? Excellent, 25 minutes. Oh, we're going to have time for more questions. Last thing, how do you update services today? How do you update your application? Do you have downtime? Do you stop it and then run a new instance of it, right?
No, you have a load balancer in front of it. So
yes, so you do blue-green deployment, right?
Yeah.
Okay, so blue-green deployment is one option. Another option also commonly used is something called rolling updates, right? So I can 5 instances of my service. Now, blue-green is great, I use it very often, but for a very small number of instances because blue-green, you know what blue-green is? No? Blue-green means that I'm going to run another release in parallel with the previous one, and I'm going to, when that is fully running and tested, I'm going to reroute my proxy to that instance. Now, that's my preferable way. We're talking about small number of instances, 2-3 instances, right? If you're talking about bigger number of instances, it's a bit expensive because if I have 100 instances of my service running, then I need 200 instances of my service running, and then it might be a bit heavy on resources. Because it's pros and cons. What I like about blue-green, it's very easy to test whether it's running before you reroute proxy. Now, alternative to that is rolling updates. Rolling updates means that right now I have 5 instances of my service, right? I'm going to stop one of those instances and put a new release in its place. Well, in that millisecond, whatever is the period of time, I have 4 instances running, so now I'm done, right? Once the new release, one instance of new release is up and running, I'm going to repeat the process with the second instance, third instance, fourth instance, fifth instance. So in worst case scenario, I have 4 instances instead of 5 instances running at any given moment. Now, your services need to be designed in a way that they're always backward compatible because during some period of time, you will have a couple of instances of a new release, a couple of instances with the old release, so it's a bit messy over there, but it's not a big deal if you have short iterations. So, Docker service update. Now, the concept with Docker service now is that you create service once in your lifetime, never, ever again, right? And after that, you always update those services. Any property of the service you want to change, you can change it instead of creating a new service. You change any property of it. And in this case, I'm going to change the property called image. I'm going to tell the service, okay, you know what? Image of this service is now different. It's called demo 1.1, right? And I want you to have 5 seconds delay between each update of the service, right? If it wasn't image, I could have changed, for example, the desired amount of memory reserved for that instance, and in that case, it would not restart, right? But since I'm changing image, you need to stop and put a new one. So 5 seconds delay, but it's not 5 seconds delay between each instance. It will start new instance. No, let me do it running first. I speak. It will stop instance, bring a new instance, wait until that instance reported it's healthy. You remember the health checks from before Docker 5? So wait until the instance is healthy, and when its instance is healthy, then it will wait 5 seconds after that, in this case, until it repeats the process with the next instance.
If you have a system like with database migration, for example, you can't deploy it that way.
Yes, you can. Why you cannot?
You do a migration for the database.
You would
you have 2 versions on the same time working.
Yeah, but your migration for database should be backwards compatible. And that's not even related to Docker. It should be backwards compatible always. Exactly.
It's a product you apply to remove a field and
why would you
expect not to have two versions of
Did you say remove a field? Yeah, that's a good example because you should just postpone removal field.
Having two different versions on the same time working, if there is an alternative for like a full, if I have to do a rollback on my migration, I can rollback, but
you can do blue-green deployment, but then, for example, but blue-green deployment you cannot do either. The alternative is to stop everything, come to the office at Sunday, and have your users not use your service for some time. That's the alternative. Now, the problem with databases usually is because people tend to have very long iterations, right? Kind of like you accumulate deltas for a month and then say this is not backwards compatible. But if you do it very frequently, then those things are usually easier. But sometimes it's unavoidable. But in most cases, actually, it requires just a bit of additional effort to make it backwards compatible. I mean, removal field, it's a very simple example. I know it's not real world, but it's still a good example because then, let's say that you're now running release 1. You want to deploy release 2, but field removal would be release 3. And it's not even for that time. Even if you're okay going Sunday, I'm not, but if you're okay with that, and if you're okay with having downtime, your users not using your service, you should still make it backwards compatible because what happens if you need to roll back, right? You cannot roll back database. We probably agree on that because the moment you start generating data, there is no rollback of database. You can roll back your service, but if your database changes are not backwards compatible, then you cannot roll back anything.
There's no rollback, there's just roll forward.
Oh, roll forward, excellent. I agree with that completely. I really do. Just that most companies freak out when I say that. But yeah, you should. But still, rolling forward is even more reasons for making things backwards compatible. Okay, so while I was speaking, you saw that 2 instances were changed to release 1.1. You see that the desired state was shut down and now it's running. And if we repeat this, now all instances are running more than, I was speaking for too long, so everything changed with 5 seconds interval between them. I could run registry, that doesn't really matter. I was supposed to show you how to automate everything I did by now and do the whole pipeline with Jenkins, but I have 20 minutes and I can run Jenkins while we speak, but I don't think that we're going to see much of it. Let me do it while we speak. Is this correct? Yeah, running Jenkins out of cluster. So I'm going to run Jenkins out of cluster. Exposing some port, blah, 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 mounting some volumes for persistent storage, and etc., etc. But let's speak. Do you want to see Jenkins or do you want to ask questions? Jenkins. Okay. So.
Actually, you have until 13:30.
Really? Oh, fuck me. Excellent. We have a lot of time, guys. So, if I look at the process of my Jenkins service, you see that it's running for 1 second already, right? And it's running somewhere out of cluster. It's running on Swarm 2. If I open now, Jenkins is slow.
Yeah.
I know. It's based on Java to begin with. There are architectural differences, the reasons why it's slow, but there are also language reasons why it's slow. You're probably getting, I don't like Java. I worked most of my life with Java, but that's kind of like, it's like when you live with the same woman for many years.
There's not a wrong tool.
Huh?
There's no such thing as a wrong tool.
I know, and I completely agree with that. It's just people
wrong solutions.
Yeah, but actually that's one of the huge reasons why I like microservices is precisely that, because I don't think that we should all program, all like organization, not necessarily all like individual program in the same language, because that's stupid. Because some languages, depending on the problem you want to solve, some languages better than the other. If you want heavy computations of some things, then maybe Scala would be a good choice. If you want heavy usage on libraries that solve all your life problems and frameworks, then Java would be a good choice. If you want something very close to the system, very minimalistic, and it actually requires programmers to know how to program, then Golang would be a good choice, and so forth and so on. So now I need, new Jenkins actually requires you to do manual setup. Don't ask me why. For security reasons, enterprise customers, I need to actually put a password there. Let's see whether all this works. Something is is not working. Let me see. Docker machine. SH swarm 2. Docker 5. Yes, I didn't see it. Excellent. Docker logs -1. 87. Let's see what's going on. Yeah, it failed. This is networking issue now. I don't know. Maybe not. Let's see whether it will work. Okay, a few more minutes until plugins are installed. That comes by default. I should have preloaded on my home, but I didn't. So you have around between 1 and 2 minutes for questions until this starts running.
Yeah, you show us.
No, you have half an hour for questions. Half an hour, guys. I can show you only code, but network always fails in conferences. Stuff like that. Questions?
Yeah, you show us how to create a cluster in a single computer. It's possible to share that cluster. For example, if we deploy to Amazon or AWS,
yes,
it's possible to share that cluster between different virtual machines. It doesn't make sense.
No, first of all, this is I'm running different virtual machines right now.
Oh, okay.
No, I'm running 3 virtual machines.
Okay, okay.
So they're and for Swarm, it does not matter whether it's different if you run different bare metal machines or you run different VMs on same bare metal machine or different, doesn't really care.
Oh.
You can even run Swarm multiple clusters. You probably don't want to do that because then you will have a real penalty in network traffic. You probably want to have 2 separate clusters in 2 separate regions. And for failover strategy, you would run on different machines of the same cluster into separate availabilities and stuff like that. They want me to show you how to create a cluster in AWS?
Yes,
I can do that. Yes. Let me see. I need to, because I don't memorize anything, I need to find instructions. Just a second. Instructions. No, those are not the instructions. No, first email, actually, here. Yeah, let's create it in AWS. I'm wasting money on you guys today.
It's not a waste, it's a good spent money.
I'm gonna run for 15 minutes, so that's okay. Okay, so I'm, okay, so next. How many managers do you want, guys? 3, is that enough? And how many workers? 5, is that enough? Micro, I'm cheap, so I'm going to use Micro. And my SH key is this one. Okay, next. Advanced options, I'm not advanced. Next, create. Capability, where is capability? What the hell is this? Okay, so my cluster is going to be created soon.
What infrastructure does your cluster have? For example, it doesn't have an ELB or
it has ELB. It has ELB. That's a new feature, still in beta, but it's public. You can sign up for. The Docker created for AWS created what's the name of Puppet-like thing in AWS? My mind stopped. Open. No, not OpenStack. Sorry. Whatever is the AWS framework for provisioning. CloudFormation. This is basically CloudFormation script. You could download it to run it yourself. It uses many more things than I would actually like. Let's see, resources, I think. Yeah, it creates internet gateway, security groups, policies, roles, ELB somewhere there as well, VPC and all those things. So just Google Docker for AWS beta and you can sign up and create it. Now, unlike me running locally, things AWS requires 5 zillions of stuff to be run, so it will take a lot of time until this is done.
Sorry?
Yes,
how
please.
do you test all these configuration and revisions? How do you have confidence that any change will not break?
How do you test this in AWS or how do you test what they did by now?
I don't know what. In general,
there is no, on infrastructure level, there's not much to test. The Docker engine is running or is not running, right? And I don't even need to test it because first time I execute any command, the Docker engine will fail. It's not running, right? Then my services themselves, I actually, okay, let me show you the code. So first of all, Jenkins, imagine that I set it up. Later on, you can if things worked, I would actually set up a separate cluster for testing. It would be also a Swarm cluster, and I would run Jenkins Swarm. Nothing to do with Docker Swarm, but Jenkins Swarm allows you actually to register your Jenkins agents automatically to the master without going to UI. A visualizer, but what I'm really trying to say, so I would have a pipeline job like this. This would be the pipeline job in Jenkins of my service. Check out the code, right, and run those things that I showed you before. Unit tests, build a container, blah, 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 same things as before. However, I'm a bit more radical. I do a shitload of testing. I have at least four parts of testing. Unit testing is the code running. Staging testing, functional testing, whatever you want to call it. Then I would deploy to a cluster that is exactly the same as production cluster, just not the same in capacity. So if production cluster is 100 servers, I don't need 100 really. But in all other aspects, exactly the same. Test whether it works there. Then I would deploy with rolling updates to production cluster and test it continuously during rolling updates. And if it goes bad, I would roll back. And that would be the last moment for me. It's acceptable to roll back during the deployment. After that, it move forward. And then actually, I have tests, the same tests that I used to run production testing. I have a separate job that actually every X amount of time, let's say every 10 minutes, every hour, I would run those tests as well. Kind of, I have a continuously running tests in production. They're very lightweight. When I say production, I'm not testing whether the certain feature works. I know the feature works because I tested those features a long time before. I'm just testing actually whether integration of different components is really happening as it should. And on top of that, running multiple instances and so on, making sure that if things fail, they're brought up somewhere else, right? And then also, I would put all the data, both hardware and all hardware data in some place, like Grafana, for example, Elasticsearch or Prometheus, and together, and also logs in central place. By the way, you cannot not have centralized logging with Microservices because you're going to die trying to figure out what's going on. So centralized logging, my preference is for Elasticsearch, but you can use Datadog or one of the services, does not really matter. So with all that, you continuously monitor, you execute your queries against the database. That's another way of testing and making sure that actual latency is as expected in those things. That's not really testing to see whether it works. We know that it works, but by gathering, for example, latency and historical latency in a part, you should be automatically scaling up and down, right? People are usually concerned how to scale up. I'm really concerned how to scale down because as soon as my traffic goes down, I want to scale down so that I free resources for something else, save money from AWS and all those things. By the way, if you're using Azure, then you can do the same thing on Azure, just Google instead of Docker for AWS, Docker for Azure as well. If you're using DigitalOcean, then you can do it yourself, use Terraform, please. Does that answer your question?
Yeah, absolutely. Thank you.
If you want to update the Docker version, for example, you have a cluster of Swarm of 3 nodes, and you want to update the version to the next one, how do you do?
Version of Docker Engine.
Yes.
Yes. Do you want a barbarian type of doing it? I mean, easy. You can simply kill the node.
But then a new version of the node is going to be compatible with the old version of the previous
node. They maintain backward. They promise that they're going to maintain this time backwards compatibility.
This time.
Yeah, this time. Because the Docker Swarm completely has nothing. Swarm from version 1.12 has nothing to do. Literally, the only thing that resembles the two is the name. It's completely new product. I don't know why they call it the same, but that's a bit fucked up. But yeah, if you want to do it nicely, then actually there is a command. I have to remember it by heart anyway. You can say you can Docker node drain or something. No, Docker node update drain. So drain would start removing containers from a node and replace it, putting it on some other node, and then that node is safe. Let's say instead of doing brute force, to disconnect from the cluster, first disconnect, that will be Docker Swarm leave, do whatever you need to do.
But this is assuming that it's not compatible with the old version.
Yeah, I mean...
otherwise you need to shut down the cluster.
Because, no, you don't need to shut down the cluster, but if you update the Docker Engine, unless things change, Docker Engine will be restarted. And all the containers running on that Docker Engine will be restarted. You're free. I mean, actually, brute force would be exactly that. Just upgrade your Docker engine. Upgrade will mean that start new release. All containers will be stopped. Docker Swarm is going to rerun them somewhere else, and then consequent releases will reschedule it up again to that node.
Okay. You really need to master the Docker ecosystem in order to be able to run it, safely and
yeah, you need,
confidently.
You need to know what you're doing. That applies to everything, I guess.
Yeah, I mean, with programming you don't. With Java you don't.
You don't need to master Java. Yeah, that's a discussion. That's what I think as well. But on the other hand, I mean, you need always to master whatever you're using. Now the question is also always whether it's easy or hard to master something. If you compare Docker Swarm with Kubernetes, mastering Kubernetes will take a lot of pain and sweat. Mastering Swarm is much easier. Now, feature-wise, Swarm has a bit fewer features than Kubernetes. That will not be the case for a long time, but today it has fewer features, so you have more features with Kubernetes, but you need a university degree to actually understand what's going on with Kubernetes, because Kubernetes is designed as assuming that everybody works in Google, more or less, on that scale.
So how do you monitor the services, for example, and stuff running in live environment? How do you know service A, which version is running? Is it helping? Is there any visual tool that you can use to monitor service?
Depends. Do you want to pay for it or not?
If it's worth.
Yeah, if it's worth.
Then you have an enterprise version of Docker that actually gives you UI. I mean, first of all, you can see everything through command prompt, right? You see the status. I was showing you statuses all the time, right? Now, if you don't like command prompt, if you like UIs, then there is Docker Enterprise something that you pay money for. If you don't want to pay money for it and you still want some UI, then you can, for example, put things into Elasticsearch or Grafana or one of those tools, Prometheus, and then have a visualization of your situation. You create your own dashboards and all those things, right? For example, for logs, I tend to use log spout. It's in a global mode, so it's a container that would run on every single node, and it would automatically redirect all logs from that server, generated from any container running there, to some central location like Elasticsearch. If you're talking about hardware, then you can use collect-D, for example, to collect all your hardware metrics. This is not directly related to Docker, and then ship it somewhere else. If you want container-specific metrics, then you can use, for example, CAdvisor running on every host that would also be sending metrics to whatever is the central location. But if the question is whether there is a solution that is baked into Docker engine, the answer is no.
Yeah. Okay.
Okay, so I was thinking that I'm out of time. I'm actually very good at time. I just couldn't run half of the things. Maybe I can try again. Let's see. No, this is not gonna. Why? Retry. No, this will not work.
Anyway, you can stop at any time you want. I mean, you have.
Yeah, I can stop anytime I want. So, what other questions?
So, do you know anyone, like a big company or someone, using Swarm in production?
New Swarm or Old Swarm? Old Swarm, there are quite a few companies. New Swarm, it was released yesterday, not figuratively speaking, but so I know, for example, the healthcare system of Australia is running New Swarm. They were just actually they were running New Swarm before New Swarm was even released, because they were members of the program of beta release that was not public. There are probably a couple of others. Compared to the old Swarm, it's much less users simply because it just appeared. I think Docker is preparing now already the transition for their enterprise customers. So all their enterprise customers will be running New Swarm anyway, because for them it will be transparent, and so on and so forth. Now, the thing is that small percentage of companies in the world use Docker in any form or way. simply because most of the enterprises live in 1999. Still, they not only they don't use Docker, they don't use kind of like they're still trying to figure out how Oracle ESB works. Things like that. Any other question? Let me try to destroy machine and start again. That might work. Machine RM swarm 1, swarm 2, swarm 4, swarm. Yes, I want to remove. Okay. I'm going to try to run Jenkins while you can ask more questions. Let's see how this will work.
Why we can just say no? We want to change to because no one knows.
Politics are fucked up. Okay, I'm going to try again to create a cluster now. This time truly from scratch, not from my phone, and see whether it works. Questions?
I want to know your opinion about, for example, talking about Swarm. Now a new version is released, so other companies are working with the old version. My opinion, or my feeling is that many other people is that Docker is still evolving, and it's not set in stone. So it's every few months you have new news. What do you feel it's worth learning deeply now, or it's worth waiting a few months or a few time until it settles a bit?
It's never late to learn.
But do you think it's worth the effort to dig in now, or just wait before it's
conceptually, if you're asking for learning, conceptually, new Swarm will not change. We know that for a fact. New features might be added, but it will not. On a conceptual level, it will not change. So whatever you learn today, it's useful. It will be useful. What do you say? 2 months from now. That for sure. Now, new features will be added. That for sure, and it will continue to be adding for years to come. So in that sense, again, there is no good time not to start. And it's not going to be. I mean, even actually, if you say time spent in Docker's old Swarm, you can say it's wasted. I would argue not, because even the old Swarm is conceptually working the same. It's just that now commands are slightly different than service discovery is baked in, for example. So you don't have a command to run console and those things. No, but
but for example, for a person that doesn't work only on Docker, which is a developer that does something, is it worth spending that much time if it's not 100% part of his job?
And we will now start entering into conflict. I think that every company should at least give every person 20% of the time to learn. Now the fact is that most companies don't, and then I don't know. I mean, you're learning it right now, so I don't know. Was this a waste of time for you or no?
I feel like there's so much to learn.
Look, next year it will be different. I can guarantee you that, simply because that's such an evolving industry, and we want it to be different, because kind of like, and there was a huge discussion with new features in 1.12, internal discussion whether to do it or no, and actually I was in a group of people that we felt that we still have opportunity to actually rapidly evolve Docker, right? Once it becomes used by every single enterprise in the world, then we will enter probably into Java mode, in the sense that kind of backwards compatibility is the only thing that matters, and evolution, we're going to leave it to somebody else, right? They're moving very fast. I like that part, but I understand that actually if you don't have time, that's very intimidating. I mean, and it's not only Docker. You can extract Docker Swarm and go for Kubernetes, but Kubernetes is also evolving like crazy. Mesos is evolving a bit less crazy, but also evolving very rapidly. It's a new part of the industry. It's going to change. It's going to continue changing a lot. Now, kind of like whether it's worthwhile, I cannot tell you in your name whether it's worthwhile. But I do believe that actually the benefits of using containers, I'm going to go in a higher level now, pay off the learning relatively fast. Because learning is not, at least with Docker, is not really steep. I mean, there are deals, you don't become an expert in a day, but unlike some other technologies or frameworks, it's not really, I don't feel it has a steep learning curve.
For example, my opinion is that in my experience that in local for development, it's very easy to use. But I'm feeling lately it's waiting until Amazon ECS is a bit more polished, a bit more easy to use before I can really feel comfortable.
No, don't. Did you say ECS? Don't, please don't. That's terrible. ECS is terrible. Don't. Just don't.
But I have to balance things that I can deliver and
yeah, exactly. You will not be able to deliver on ECS. It's horrible.
Okay, so
yeah, no, it's ECS is
the
horrible.
It's also intimidating. So this is intimidating also for me. Also, you showed about.
Yeah, I mean, yeah, but you can learn this I mean, if you dedicate, everything I did, dedicate kind of a couple of few full days and you will be half expert, I guarantee you that. Yeah, buy my book, yes. Buy the book. There you go. You can read it during the weekend. Too, maybe.
I think that in a pair of days, it's
I mean, there is the 80-20 rule, right? I don't know if you're familiar with that. In 20% of time, you can learn 80% about something, and then you need 80% of time to master the rest of 20% that makes you really an expert, right? Those 20% of time to figure out 80% of what you need, and that's almost everything you need usually. At the beginning, it's going to be relatively quick. I don't know how fast you learn, so I cannot tell you the exact number of hours, but it's relatively fast. You can go with, for example, things like Rancher that will let you do things through UI. Rancher. Rancher.
I don't know.
They have Rancher OS and Rancher UI or whatever they call them. It actually lets you do click, 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 and then you get services running. I'm very much against UIs because I think that they're very dangerous in the sense that you have a false impression that things are under control, and then when you need to actually get to the rest of 20%, it's usually more expensive to get there than if you understand from the very beginning what's going on. Same thing, like, I don't know if some of you might be older, kind of like when during the 90s when it was popular to use HTML editors, drag and drop Dreamweaver. Any of you use Dreamweaver? Like, any of you read the code afterwards from the Dreamweaver created? Did you actually manage to understand what's going on and kind of fix the problem? Maybe I was stupid, I don't know, but I was not able to understand what's going on. For a year, something I was dragging and dropping, and when I had to fix the problem, I just changed to non-web development because I was my own code. But yeah, it requires dedication. I mean,
I need to try it till at least 2 days to see if I can do it. Thanks.
Don't forget about the Amazon instances you run.
Huh? Wait, I need to stop them. No, they're still running. Now it's creating security groups, stuff like that. I mean, Amazon is great if you want really, really high security, but then until everything is created, it can take ages. And now, actually, I'm going to show you the time. Actually getting I'm adopting fully Catalan culture. I'm going to delete it because I'm going to become cheap. I wasn't cheap before I came here. But yeah, I'm becoming Catalan, cheap. Destroying, actually. I don't know even whether it's with active internet connection. Yes, he hasn't given me internet, so he's going to run until tonight. Fuck me over, guys.
Who will buy your ear?
Yeah, okay, then 2. Whichever deal.
Okay.
Okay, anyway. Excellent. So, what else can I do for you guys? I was too fast and then faster than I should be. And things don't work.
You have a Docker captain here to answer all your Docker questions.
Yeah. Not all. I'm not allowed to speak about release 1.13. Anything before that, I can ask.
Were you able to run Jenkins finally, or?
No, it's, it failed. It showed the message and then said it's okay. No, I actually, sorry. No. IQ machine's running, okay. I need to repeat the commands. Let me see. Create my cluster. You know, I read the command so that it looks like actually I know what I'm doing, but actually somebody else wrote it for me. What happened here? Let me see again. Yeah. This is missing. Okay. Jenkins, awesome. Now you will see how painful things are because now since I don't have it preloaded, it will need to download. No. It will need to download Jenkins image and that will take some time. Where is it? Okay. Yeah, it's preparing. It's going to be preparing it for a while. Preparing means it's downloading the image. Anything else? Last opportunity. Doesn't have to be related with Docker. Yeah, sure.
What would be the argument to convince somebody that don't believe or don't trust in Docker in production? What's off, like?
Don't believe or trust Docker in production.
Yeah, like I see it, but a lot of people will see it as very cool and very promising, but it's not really yet not how it cooks.
No. I mean, no. I mean, big companies run Docker. Now, the fight is not anymore about Docker. Kind of like whomever lives in 2016 acknowledge that Docker is the way to go as a container solution, except if you work for Google, and then you acknowledge that Rocket is a solution, right? We can discuss about differences there as well. The real kind of fight right now is which cluster and the cluster orchestrator to use, Swarm, Mesos, or Kubernetes. That's the real kind of like Docker. That's already done deal. Nobody's even trying to actually dispute that. What we're trying to kind of figure out now how to orchestrate containers. That's the real kind of question. Whether any of those three or something new will pop up. And there's a lot of politics now involved because Docker is becoming critical for many companies. That's like, for example, there is unofficial alliance between Red Hat and Google to destroy Docker as a concept. To destroy Docker Swarm because Google sees Kubernetes as a reason people are going to start using GC instead of AWS strategically.
You don't be allowed to use it.
Huh?
Kubernetes, right?
Second?
The Docker container engine from Google, they only allow you to use it with Kubernetes. You can't use it with Docker Swarm.
And really? Nothing prevents you from setting up yourself. You get servers.
I mean, if you use their
if you do use kind of like pre-baked container solution, it's Kubernetes exactly. That's kind of what they think will distinguish them from Amazon. Kind of like added value in a way.
They're telling that the Swarm bundled with Docker is like Internet Explorer bundled with Windows.
Yeah, I know. They say that there is part of truth in that, but the conversation is very unhealthy at the moment because it's not fueled by real opinions from neither of the sides, but it's fueled by political agendas that are related to what I was explaining, kind of. And Red Hat, for example, what happens with Red Hat OS if people jump into Docker, right? Kind of, it's very disputed. Not only that, but Red Hat acquired Ansible. That is even more question: what happens with Ansible if people adopt containers and stuff like that? So there are many. It's many fights going on right now, motivated more by enterprise agenda than real reasons behind it. Which I'm not saying that it's not true that bundled might be seen easily as.
You're saying that Ansible and the container is mutually exclusive, but Is it
It's inclusive or exclusive?
exclusive?
Yes,
It's not, or it is?
it is. No, it's not exclusive, but kind of. So you're gonna, let's say, and I'm going now extreme. Most people are gonna combine containers with non-containers. So I'm gonna exclude now, I'm gonna comment only on cases where you run containers, right? So what's the process? Create a new server with Docker engine, right? And start running containers. Now, yes, I can use Ansible to do apt-get Docker, right? But
Yeah.
kind of, if that's all I'm doing, I can just as well create a shell script. No, it's very limited. I'm exaggerating. It's not only Docker engine. You might open some ports and few things, but it's kind of so limited still compared to before, because most of the things that you were doing now in Ansible directly on the host now is happening inside of the container. Ansible create that perversion of a thing that allows you to create containers with Ansible. Just don't. It makes no sense, no point. And most of the companies do those things. Docker is such a big money maker today that every single software company wants to put Docker sticker instance that kind of we do something with Docker, and then they just invent. Some of them do really cool stuff, like Flocker, for example, and some of them do stupidity just because they don't know what to do with it. Kind of like creating containers with Ansible. Really. And I'm telling you that as a person who thinks that Ansible is one of the best things ever happened to our industry. I love Ansible. I really love it. But they're just going astray. They were bought by Red Hat, so they need to start thinking in different directions.
Another question. We keep going in more in the deployment techniques, and now we have serverless and Amazon Lambda that they have some kind of try to solve the same thing in different ways.
Yeah.
What's your opinion on the?
Okay, first I must say that I think that the person who came up with the name serverless should be hanged from the window. Because it's not true that there is no server. It's just that you don't care about, somebody else is maintaining it.
They call it or something.
Yeah, that would be the same thing as actually EC2s are called VMless, or whatever would be the shortcut, kind of like there are no VMs. There are VMs, but you're not creating them. Same thing with, no, I think serverless is very useful for certain use cases, right? When your latency is not important, I think serverless, for example, for what would traditionally be some batch tasks, right? Run it once and disappear from face of the earth. I think that's a very good model. If you have very low traffic on something, some API, that might be a good model. But there is a point after which actually financially to begin with serverless does not make any sense. If you have a huge traffic, putting API on serverless would actually cost you more than costing you less, and would give you relatively high latency, which we don't want. So it really depends on a case to case. Like anything, kind of you need to understand what it does and then choose the right use case for the right tool. So kind of fire a task periodically. That's a good use case.
Yeah, for synchronous processing or messages, but it looks like for certain use cases, it looks like from the outside much simpler to configure and have something running and without having to worry about.
It's not something running. Something will be running and then stop running, and will be running again and then stop running. That's the model.
It simplifies the process.
Yeah, it does. It does. I mean, I think it's cool, and that we're gonna be talking about it next year in a more serious way. I think as industry. Right now, there is very tight coupling between service provider and the code you're writing, which for me it's unacceptable. I reject any serious usage of lambdas or any whatever is the name of Azure and all those things. I don't want to couple my code with service provider, hosting provider.
Yeah, that's it.
There are now some initiatives to make it open and all those things, some kind of a standard. But then today, if you want to use one of those open initiatives on AWS, you will need to set up your non-existing server yourself, and then it kind of loses the point, because once you start managing the server yourself, then kind of like, why the fuck do I want serverless? If I'm managing the server. The kind of cool thing about serverless is that they think about my server, right? That's a major advantage, because without that, you can accomplish serverless architecture with containers as well. Kind of run a container when you, like I run it, and when it stops, just let it disappear automatically after 15 seconds, just in case if a new request comes. No, that's more or less the model of serverless. But it's very interesting. But I don't think we're there unless you actually sign the contract with blood that you're gonna forever and ever be with AWS.
I like, for example, the Docker that you always can take this unit and deploy it anywhere. But at the same time, for example, to configure a message consumer, it's super fast, and Amazon, they make it very easy to catch you and go there. So it's like.
I think it's cool. I mean, I'm 100% certain that it will have a future.
When you do the integration test, and you set up a cluster only for integration test, do you set one cluster per running instance?
No. I set a cluster that is almost the same as production, meaning that everything there, the whole production services are running, and I will update the release of my new, update the service with the new release in pre-production, and then in production. They're identical. They're not identical in number of instances, because if the number of instances is huge, I might not need really hundreds of instances of something. But excluding number of instances, they're identical, yes. It can be 3 server clusters, doesn't have to be big, doesn't have to be expensive. I mean, it also depends on your team, right? If you will be testing in production anyway, I hope you're testing in production anyway. And I mean, if your team is really kind of knows what they're doing.
You can find ways of not testing in production using production traffic anyway, and not having to.
Yeah, I mean, but using production traffic to do what? To test.
Yes.
So that's contradictory, not testing to test. It's testing.
Yeah, that's what I mean. You don't need to test in production.
But that's test. But
okay, that's what you mean.
Okay, testing is me checking whether it's working,
okay,
and performing some actions in case it's not. And not even necessarily working, because tests are often in production. I'm not that much concerned whether it truly works or not, because I know it works. Kind of, it's been working yesterday, and it will continue working for quite some time, because it's designed to be fault tolerant. But my tests are more concerned, kind of like, so let's say, go to this API. The traditional integration test would be go to the API backend that returns something from the database. So that way I test integration between backend and database. That's great. That's very easy. That's not a problem. But I want in that test, I also tie that test is considered failed if it does not receive response in certain amount of milliseconds. So actually, production testing is not only whether integration works, but actually whether it works as expected. And as expected involves a bit more than simply yes or no. It's kind of like, yes, but with these conditions, with this period of time and all those things.
And what happens if you're running different versions at the same time with integration tests?
I assume that they're backwards compatible. I mean, now, with or without containers, for example, depends always which part of the system we're talking about. For example, if you're talking about backend, API backend, and again, this is nothing to do with containers, your APIs, when they change conceptually, need to be versioned no matter what, whether you're using containers or not, because you don't know who is using your API, right? It's not only about running 2 releases in parallel, 2 versions in parallel, but also when you change your API, you cannot break compatibility with the rest of the services that might or might not be using it, because then they will stop working, right? So the services APIs need to be versioned when they break compatibility.
But they need to be isolated also.
Huh?
I guess they need to be isolated.
What do you mean isolated?
I mean, if I write something into one database and another test is also writing in that container, and we're running on the same cluster, then I don't know which of the containers is getting information.
Which of the instances are giving, why do you care which one is giving?
Because then I have, I don't know, maybe duplicated information or whatever.
Whether you have, okay. Okay, but then if you detect actually, if your tests detect that actually they themselves produce duplicate information, you just found a bug. Great. Your applications are not supposed to, in real world, outside of tests, right? You just describe the scenario that your tests, bad negative scenario that your tests found, because your users are going to invoke your services in concurrent manner, in parallel, and all those things. And so you just found the bug that your service is not writing things to the database in a correct way. But things need to be, I mean, we need to accept that as an industry. It's unacceptable today not to run multiple instances of our services. It's unacceptable today, right? It was maybe before, but now it's unacceptable. And multiple instances means that you need to be stateless, and you need to have a backend storage somewhere, right? And that's simply how it works. It's not a choice anymore. I mean, it is a choice if you're a bank and run COBOL still.
And the other question I have is, like, when working with AWS or Google Cloud or whatever, always might have these how volumes work, because everyone says don't use volumes or like don't overuse volumes.
Exactly. Step number one, figure out whether you need volumes. And then if you do need volumes, then you can go, first of all, you can do with containers everything you were doing before. So whatever system you had for persisting data before, you can do it with containers. That's no-brainer. NFS volume attached to every server of your cluster, right? That's probably the traditional way how people usually use it. And then whenever it's running, actually it will be able to use the same volume. It will be very slow. NFS fails every once in a while, but what can we do? That's what we use. Now you can go to more advanced tools, like you can plug in additional volume drivers to Docker, and they use something like Flocker or Rex-Ray that will actually, the drivers that will move the volume when a container moves. And that way actually give you high latency, because you will not have volume somewhere in some other server, right? Because it's always expensive, more expensive. It depends what you need. But to start with, NFS allows you to do whatever you were doing before. And yeah, figure out, because usually people try to translate the same way of thinking before containers into containers, and that creates a problem. Like, example I often use is a database. Do you need to persist database data or not? For example, what would you say?
What?
Do you need to persist database volumes or no?
It depends.
It depends whether you have multiple instances of a database, right? And then let's assume that you do, because you would be insane if you don't, because then you have a single point of failure. If you have multiple instances of a database, then most likely, let's say Mongo, for example, every database has a different name for the same thing, but you would do some kind of replication or across those multiple instances. All those multiple instances would have the same data, right? So if one instance fails, or whatever orchestrator you're using, a new instance will be brought up, and it would connect to your cluster of databases and get the data from the database itself. That's a recommended way, with or without containers, right? So kind of periodically you take backups. You don't have to persist volume to take a backup, because you're hopefully with or without containers not taking backup but copying files, because that will give you corrupted backup. You're creating backup by actually issuing backup command to the database itself that spits out a file for you, right? Zip or whatever it is. Things like that.
Okay. Maybe we can continue. If we have more questions, we can continue talking afterwards. Thank you very much, Viktor.
Thank you. Some Agile teams do, but it's not really prescribed as part of the Agile movement. So from Agile, from Agile movement, more or less, in most cases, we exclude completely operations. Like, you're Agile, and then you have a department of operations that you need to wait for 2 months until they actually do something. Now we go to DevOps. DevOps is in a way continuation of Agile. It's kind of evolution of Agile, at least how I see it. It really makes the team being truly self-sufficient, because it includes all the operations and monitoring and God knows what tasks that we were doing before, separately from the development teams. The result of all that is that we can finally do many funky things that we couldn't do before, or we couldn't do before really well. And one of those things is continuous deployment, my favorite, meaning, you know what continuous deployment is, right? Also, you commit something to repository, and from there on you go and take a coffee because things are gonna get to production in a fully automated way, and there is no manual action after the developer commits code to the repository. So, the thing is that now you need to know your more times the things. You're not a coder, you're not a tester, you're not an operator. You need to know everything and then specialize into whatever you want to specialize with. You need to understand the process, because if you don't understand the process, and if you're not capable of doing all steps in a process, then you don't know how to do your job either, because you don't know how to, you cannot really design your services well if you don't know how they operate with other services. You cannot design your services well if you don't know how they're going to be deployed. You need to know all those things only to go back to what you're really doing, your specialization, and do it right. Right. So, I said I'm going to go fast. Any questions before I start doing, showing you some code? Questions? Yes, please.
One general. So, microservices as a concept, in your experience, would you dig into microservices? For example, you're starting development, or you're part of a new effort to develop something.
Something new.
Something new.
Okay.
Would you dig into microservices architecture from the day one, or you would develop monolith?
No.
And then, if it needs, you would scale by introducing microservices and something like that?
No, I will start with microservices immediately, because if you don't start with microservices immediately, then you're gonna fuck it up in a monolithic way, and then you're gonna have problems to do it afterwards. Microservices are not really hard. Microservices are, in a way, the same thing as object-oriented programming. I would even say that
it's easy to implement, but it's
Yes.
so hard to maintain. It's so
Right.
difficult to deploy because there's so many moving parts. You need people to.
Okay. I make a deal with you. I show you the code, and after that, if you continue telling me that it is hard, we're going to discuss it.
Okay.
I'm going to show you it's not hard.
All right.
Is that the deal? Excellent. Any other question? Yes, please.
You said that everybody needs to know everything and then you specialize. Do you really expect every team member to know everything about how the pipelines work?
Yes.
About the infrastructure?
Yes. Yes. I do really expect that. Yes. No, when I say everything, I don't mean to be expert in everything. I'm not saying that. So I fully understand that if you're a coder, you cannot know everything there is ever to know about databases. Just let's move it a bit backwards in time, right? You're not an expert in database, I understand that. But does that mean that, for example, you're not capable when you do your code to do SQL query? Does it? No, of course. You need to know if you have enough knowledge about databases, even though you're coding your service, right? The same applies to, if you're a coder, that doesn't mean that you don't know how to test. You do write your tests? Same thing, right? I'm just moving it a bit further and saying that you need to know how your service is going to be deployed. You need to know how your service is going to be monitored, because if you don't know, nobody can know. I mean, to me it's a ridiculous idea to say, okay, I developed my service, here it goes, put it to production, and whatever is the So, my name is Viktor. I work for CloudBees. CloudBees is a company behind Jenkins. We do Jenkins stuff. I work a lot with Docker engineers. I'm not employed by them, but you can say I'm an evangelist or something like that for them. A couple of books, not important. So Docker containers. Who's using?
No, go back to books, please.
Yeah, those are okay. The third one, don't bite. It's really awful. And I'm not exaggerating. It is. The first two are good. If you want to go into DevOps stuff. This is DevOps in general. This is about Docker Swarm in more details. Buy it now. That's commercial. Okay. Enough of books? Excellent. Who's using containers today? Okay, so I don't need to tell you what containers what containers are. They're portable, blah, 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 blah. Bare metal. Okay, skipping.
This is going to be fast.
Yeah, it's going to be too. No, I want to go to the hands-on part as soon as possible. Just like with books, say stop and I go back and explain you what containers are, right? You know what containers are. They're cool, they're sexy, and all those things. And we were using monoliths in the past. Hopefully we are not going to use them for long because they're awful. We are using microservices today because they have many advantages. Advantages is that we can have small teams working on applications, have autonomy, and all those things. Right. Going fast. The reason why are we using microservices now? Microservices exist for a long time, right? Who's using Linux? You're using microservices. Linux is microservices. Linux is a bunch of small programs that do a very specific type of tasks, and then you combine those programs into a pipe divided by pipes. Input of something becomes output of and becomes input of something else, and so on and so forth.
And
Linux is microservices.
And then it doesn't work.
Linux.
No, I mean the pipe.
Yeah, of course. If you don't know what you're doing, it doesn't work. For the rest of you, it does. I'm kidding, partly. So why are we using microservices now? And why weren't we using microservices or services before? And we were not using microservices before because they were very complicated to do and complicated for many reasons. One of the reasons is infrastructure. Because if you're going to have hundreds of services and each of them developed in whatever the team thinks should be developed in, and we want that because we want to give teams autonomy. You can do in Go, you can do in Java. Don't do in Java. You can do in Go, you can do in something else. That's okay, but it produces huge problem with infrastructure because how you're going to set up servers that can actually support anything that anybody can ever imagine, right? Very complicated. Java 7, Java 8, oh no, I want Java 6, no, I want Java 4, and I want Golang. It's really, really complicated to set up infrastructure for microservices. Now, with containers, and that's the reason why actually everything is coming now together with containers, all that infrastructure mess becomes relatively easy. Not easy, but still much easier than before. The reason is because inside of containers you can put everything you need, and that's completely isolated from any other. It's not completely processes inside of a container isolated from processes inside of some other container. So you have no conflicts in that sense, and your infrastructure is basically bare metal with only Docker and nothing else, right? And that's why Red Hat is now going crazy, trying to completely destroy Docker, because if Docker succeeds, then Red Hat is going to completely disappear as OS because there is no real reason to have Red Hat or Ubuntu or something like that, right? Complete change in how we manage infrastructure today. Am I going fast?
Yeah.
Yes. Complete change in how we do infrastructure
The stuff with Red Hat being distinguished, how's that going to happen?
How is that going to happen? Let's say that we all adopt containers. Okay. Imagine, because Docker engine it will work, right? So if I'm going to run it with Docker Compose. For those of you who don't know what Docker Compose is a way to declaratively specify in a YAML format all the arguments that you would normally run manually if you would do Docker run blah, 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 blah. So I'm going to run, so I say, okay, I don't know really what you're doing. We agree that your unit test will be called unit test. I don't care what's inside. I'm going to run a command for every service that is going to be always the same. It's going to be Docker Compose. -f is the name of the Docker Compose file. I want to run whatever is there. I'm going to use argument --rm. That means that when I'm done with this container, when I'm done with unit tests, I want you to remove it completely because I don't need it anymore, right? That's kind of leaving my server, resources of my server available for something else. I hate running things unless it's really needed. And finally, the service I want to run is called unit, right? Now let's see whether the network works. And this is a good, I downloaded the MongoDB driver among others because the service needs Mongo. I have to download a few other things before it continues. Questions?
About the Docker Compose, you had like an app image then a unit. I didn't understand the meaning of.
Yeah, this you're referring to this, right?
Yeah, and the app.
Yeah. So in Docker Compose you define services, right? Service. This is the name of service. This is the name of the services. Whatever you want to put. It's a name that it's provisional. Whatever you want to put. And inside of a service defined by a random name, you use Docker Compose syntax to define stuff. This is a base image Golang, volumes, working directory, and command interface. Does it pass?
So the app there is like a what for the other?
No, the app is another service, and this one I will use soon to build my container later on, my service. And I have here, for example, another service called staging depth. That is going to run my service in a staging environment and has a dependency on database and so on and so forth. I'm going to go through all of them. But I think that the only important thing for now is that you can define as many services as you all want, and each of them has different meanings, whatever you want the meaning want to be. Okay, and my tests are finished, right? All of tests passed. I'm a really lazy programmer, only 66% coverage, and everything is really peachy. Now, this in itself already would be probably, if you went to your IT department or whatever you have in your company, you told them, hey, you know what, I need to go compiler running on a server, and I need MongoDB, and I need a bunch of other things, they would probably tell you come back tomorrow. And that's only if you're a very fast company. If you work for one of the major banks in Spain, they would probably tell you come back in 6 months, and you will not get it then either, because we don't allow anything that is not Java 4. And if you remember, when I run the command, if I go back, where is it? Yeah, so I download the dependencies, I run my unit tests, and I build my binary, right? So if I look at my directory, you can see that my binary, the result, my service itself, is built as part of my process, right? And it's something on somewhere on my hard disk waiting for me to do something with my binary. So let me build the service. Now that I know that service first round of tests worked, unit tests were successful, I can build my service. And to build the service, use something called team in charge of production operations will know what to do with my service. They have no bloody idea. Of course they don't. They can create tools for you to use. They can create processes for you to follow. But it's ultimately your responsibility. It's more or less what Amazon is promoting with 2 pizza teams. Do you know what 2 pizza teams are? So basically I have a team that is sufficiently small that I can feed them with 2 pizzas, and they're responsible for a service. Meaning that if it fails at 3 o'clock in the morning, they'll call somebody else, some random operation dude to fix it. It's your service, you did it, you fix it. That's attitude. Okay. Does it answer?
Yeah.
Okay, so let's see. It's very likely that network is going to fail, so let's see whether this will work, right? So I'm going to go to one of my services. So this is this is my service. It's called Go Demo. I already created, the only thing that I did in advance, I created virtual machines on my laptop. Yeah, by the way, if you want to do the same thing that I'm doing, this is the address of the presentation, only the highlighted part. I advise you not to do what I'm doing, simply because network is almost certainly gonna fail. You can do it at your home, but if you insist, you can do it here, what I'm doing as well. But then you need to tell me to slow down, because I'm gonna go relatively fast. Okay, fair enough. So let's see. I have a single machine right now. I'm going to instruct my local Docker client to point to that virtual machine so that I can do things remotely against that virtual machine. So let's say that I have a service, and I do have a service. Let's say that I did a commit to repository, which I did. And the first step in my pipeline or my deployment flow, or however you want to call it, would be to run unit tests, right? First 2 actual steps are to run the unit tests and to create a binary from my code. It's Go, so it requires a binary, right? Most languages do. And by the way, this machine that I'm using right now has absolutely nothing but Docker, right? And I assume, when I start with Teams, I assume that you know what you're doing with your service, and your server is going to have nothing but Docker. I don't care whether you're developing in Node.js or Python or Java or whatever you're doing, right? So, and we made, let's say that we made naming convention, and then we all agree that the unit tests are going to be called units, right? Just a naming convention, nothing else. And the team comes and say, okay, excellent, I have a service is right. for me to run unit tests, I need Go, because service is written in Go. So I'm going to use image called Golang version 1.6, right? And inside of container, I want to expose the current directory, wherever I am right now, is to be inside of container this directory, USR, SRC, my doesn't really matter. And I'm going to expose one more directory from the host, TMP Go, to be inside the container is going to be mapped to directory Go. The reason for that is because Go will, like most languages, will, before it runs tests, it will download dependencies, and I don't want to download those dependencies every single time I run unit tests, so they're going to be persisted on the host. Working directory, this is what's going to happen, but actually, basically, the only really important thing is this. I'm not going to teach you Go today. Anybody working with Go? So I'm going to download my dependencies. Command is really not important, just to know that the dependencies are going to be downloaded. I'm going to run my unit tests and get a test coverage report. And I'm going to build my binary, right? I'm doing the same thing as I would do without containers. The major difference is that things are going to happen inside of containers, so they have no dependencies to the infrastructure, right? Doesn't really matter what my server is, doesn't matter what's installed over there, as long as I'm not saying that, right? What do you need if you want to run containers? You need OS that has Docker engine and 3 more things, right?
Which might be Red Hat.
No? Yeah, no, Red Hat is not 3 more things. Red Hat is 300 zillions of things on your OS, right? You don't need all those things. And we want to go minimalistic, and we put all the things that we need. That's why CoreOS started getting popularity. Ubuntu Docker is becoming popular. New OS, I'm not allowed to speak about it, but new OS from Docker is also coming out, and so on and so forth. Many Linux distributions. It's still going to be Linux. It's just that this distribution of the Linux is going to be much more minimalistic, right? Because things are moved inside the containers and not running on OS.
I see.
Right. And that's why Red Hat needed to join forces with Google. Now they're fighting against Docker and a few other concepts and companies that are moving in that direction. Okay. So, and another reason why things are becoming different is because we are now going into immutable everything, right? You're not supposed to change anything in your host. Everything is immutable. Everything is unchangeable. Meaning containers are immutable, and you're not supposed to even to have SSH access to your servers because you don't need SSH access anymore. If you need access, you're doing something, either 2 options: you're doing something terribly wrong, or you have your cluster is 2 servers in total, right? Very small. Okay. So problems with all that is that changes become a cluster, and when I say cluster, everybody says we have a cluster. The fact that you have like a couple of servers or a couple of tens of servers does not mean that you operate on them as a cluster. Cluster means that it's a one unit. It's not kind of, you don't deploy to a server X. You don't put the name to your server and say this server is called Garfield, and that's where I'm deploying my application. Now you deploy to a cluster. Cluster has, I don't know, 200 CPUs, terabytes of memory, stuff like that. It's one unit, no matter how many servers it has. Pretty much like big guys, unicorn companies are doing for a long time. Like Google, for example, has containers, I don't know, 15 years. It's just that they were very hard to manage. So now, if you start using a cluster, then that means that you need to change your architecture. And that means that you need to start deploying immutable artifacts, containers, or immutable even VMs. We were doing that before containers. You're starting to build stateless services. Services needs to be stateless if you want to do what I'm going to present here, because if they're not stateless, then you cannot scale up. You cannot recuperate from a failure. You cannot do many of the things that we want to do today. And everything communicates through service discovery. Who knows what service discovery is? Excellent, half. That's a good percentage. For those of you not, in other words, what using service discovery means that whomever of you is using configuration files, throw them to the trash because they cannot be used anymore. And the reason why I cannot use configuration files is because you don't know where things are. Because you cannot put in a configuration file and say, this is the IP at the port of my database. Because database might be here, and then the server might fail, and it will be recuperated somewhere else. So things are all the time moving, fluctuating, and if you have code values in your code or configuration files, you're going to fail as well with those services. So configuration files out, service discovery becomes a norm. and we need new processes. Agile, right, appeared, I don't know how many, 20 years ago, 15 years ago, nobody knows, appeared a long time ago, we all like it and all those things. And it changed drastically how we develop software, right? We develop in small iterations because waterfall nobody wants to use anymore, and self-sufficient teams. Now, self-sufficient teams, that's a problem because Agile teams were never self-sufficient, never, right? Self-sufficient in Agile terms means that I have all the team knows how to get the requirements, how to develop, how to test, right? In Agile, that's not really self-sufficiency because they don't know how to deploy code and they don't know how to monitor the deployment of the code and recuperate from failures automatically. I mean,